Question 1. Write the number 3,107 in figures. So we have 3,107. So we've got thousands, hundreds, no tens, and we've got ones. So we're going to have a 0 here in the tens column. So we've got 3,000s, 100, 0 tens, 7 ones in figures there on the answer line. Question 2. Write 3/10 as a percentage. To change a fraction into a percentage, we can multiply it by 100. This is a calculator paper, so I'm going to type the fraction into my calculator and multiply by 100. So that is 30%. Question 3. Simplify m, add m, add m, add m. So we have 1, 2, 3, 4 m's added together. So we have 4m in total. Question 4. Change 4,000 grams into kilograms. So 1 kilogram is 1,000 grams. So if I divide 4,000 by 1,000, that will tell me how many kilograms. So 4,000 divided by 1,000. It's a calculator paper, so use your calculator. So the answer is 4 kilograms. Question 5. Write these numbers in order of size. Start with the smallest number. So the first thing to recognise is we've got positive and negative numbers. Negative numbers are smaller than positive numbers. So let's start looking at those. We've got -5 and -2. -5 is smaller than -2 because it's further away from 0. So we'd have -5, -2, and then it would be 3, 7 and 9. I did it here just in case I got confused. Now I'm going to transfer it to my answer line. Question 6. The diagram shows a shape on a centimetre grid. Find the area of the shape. So the area is the inside of the shape. So it's on a centimetre grid. I'm going to count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it has an area of 14 centimetres squared. Find the perimeter of the shape for part B. That's the outside of the shape. So we're going to count all the way around the outside of the shape. So we're going to count the sides of the squares. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it has a perimeter of 18 centimetres. Question 7. Here is a 4-sided spinner. Samina spins the spinner once. Part A. Choose the word that best describes the probability that the spinner lands on a 2. So there are 4 possible answers. There are 4 possible sections of the spinner that it can land on. 2 of them are a 2, which simplifies to a half. So it's an even chance, 50-50 chance that the spinner is going to land on a 2. Part B, choose the word that best describes, I better write that there actually, there's a line for it. Choose the word that best describes the probability that the spinner lands on a number less than 4. Well, the numbers are 1, 3, 2 and 2, they're all less than 4. So it's definitely going to happen. So the word that we choose is certain. Ralph rolls a biased dice once. The probability that he gets the number 5 is 0.4. Work out the probability that Ralph does not get the number 5. So probabilities sum to 1. They're out of 1. The probability scale goes from 0 to 1. So if the probability of getting a 5 is 0.4, the probability of not getting a 5 will be 1 subtract that. Remember, you've got a calculator if decimals are not your favourite thing to work with. So 0.6, so that is the probability that Ralph does not get the number 5. Question 8. A quadrilateral has 4 right angles and 4 sides of equal length. So 4 right angles, 4 sides of equal length. Write down the mathematical name of this quadrilateral. Well, it's a square, because if it has 4 right angles, it could be a square or a rectangle, but the fact that all 4 sides are of equal length tells us that it's a square. The diagram shows a solid shape, so here's a solid shape. Part B, write down the mathematical name of this shape. So this is a cuboid. It's not a cube because all of the side length, all of those edges are not the same. We've got this rectangle cross-section shape running through it, so this one's a cuboid. Question 9. The table shows the number of books read by 4 people in 1 month. So we've got our 4 people and the number of books they read. Work out the median number of books read. So the median is the middle. So I'm going to write the numbers in order from smallest to biggest and then find the middle number. So 1, 5, 7 and 9. And then I'm going to cross off from either side. So if I cross off here, and you're aiming to get the middle number. Now if I cross these 2 off, I'm going to have no numbers left. So the median has to be in the middle of these 2 numbers. So between 5 and 7, the middle number is 6. So the median is 6. If you weren't sure, on your calculator, 5 plus 7, oh no, that's 5 plus 7, and then divide by 2, and that'll tell you that middle point. Find the range. So the range is the biggest, subtract the smallest. So the biggest number is 9, the smallest number is 1, and 9 subtract 1 is 8, and pop that on the number line. Part C. On the grid, draw a bar chart to show the information in the table. So we're going to have our people here along the bottom. So this is going to be the person, and then along this axis we're going to have the number of books. Now we need to figure out a scale for this. So our biggest number is 9. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. So each square could be equal to 1. And I would recommend you using a pencil in case you need to rub out because you make a mistake. And then along the bottom we're going to have these people. So we've got 4 people. So if I put 1 person there, 1 person there, 1 person there, and 1 person there. So we're going to have that's that person, that's Martha, Kezia, and then Tabby. And what you'll notice is I've planned where they're going to go so that I can leave an equal gap between. You don't have to, but most of the time that's what you see. So the first person, 7 books. So we're going to use this here and we're going to go up to 7. And that's their bar drawn. The next person is 9, leaving that gap, remember. So we're going to go up to 9. And then the next person was 1. And then finally, Tabby is 5. What's important with your bar charts is you have your axes labelled, you have your scale, and then you've got obviously this criteria at the bottom here. Your bars are equal width, and if they have spaces between them, they have equally spaced out spaces. Question 10. Wayne begins walking at 8:30 a.m. He walks for 1 hour and 45 minutes. Wayne then rests for 15 minutes. He then walks for 85 minutes to a cafe. Does Wayne get to the cafe before 12 noon? You must show how you get your answer. Okay, so if he starts at 8:30 a.m. and then he walks for 1 hour and 45 minutes. So 1 hour on top of 8:30 would be 9:30. We're still in the AM here, remember? And then that 45 minutes, we have to remember that there are 60 minutes in an hour. So 30 of those 45 minutes would get us to 10. But then the other 15 would get us to 10:15. That's to account for that 45 minutes there. So we're currently at 10:15. He rests for 15 minutes. So 10:15 plus 15 minutes takes us to 10:30. Then he walks for 85 minutes to a cafe. Remember, there's 60 minutes in an hour. So 85 minutes is 1 hour. And then if we do 85 take away 60, it's 1 hour, 25 minutes. So we're going to add an hour on. And then 25 minutes. So this is what time he gets to the cafe. It's before 12 noon. So yes, he does. Question 11. Gabriel thinks of a number. He multiplies his number by 5 and then adds 7. His answer is 72. What number did Gabriel think of? So let's call Gabriel's number X. First thing he did was multiply by 5 and then he added 7, which gave him an answer of 72. So I've formed an equation here that I'm going to solve. So I'm going to subtract 7 from both sides because 7 is the inverse, subtract 7 is the inverse of adding 7. So 5x equals 72, subtract 7. I'm using my calculator because it's a calculator paper, I might as well. And then this is 5 times x, so I'm going to divide by 5. So x is 13, so 13 is the number that Gabriel thought of. You can double check that, you can put it back in. So 13 multiplied by 5 and then add 7. Yep, that gives us 72. Question 12. Some students took a guitar exam. The pie chart shows information about the grades the students got. So it's a pass, fail, distinction or a merit. Write down the modal grades. So the mode is the most common. So modal is most common. So we're looking for the biggest section of the pie chart. The biggest section of the pie chart is merit. So that is the modal grade. 7 students got a distinction. Part B, work out the total number of students who took the guitar exam. So we're going to work with degrees here. So we've got degrees and then students. So 7 students got a distinction. So those 7 students are worth 105 degrees. Okay. So what we're going to do, we're going to go to 1 degree and then to 360 degrees because we want to know what the whole pie chart is worth, and a circle, the angles inside a circle add to 360. So to go from 105 degrees to 1 degrees, we're going to divide by 105. So 7 divided by 105. And then we're going to times by 360. So there are 24 students who took the guitar exam. Question 13. Rowena drove from her home to a beach. Here is a travel graph for her journey. So this is the distance and this is the time, and we've got the journey plotted here. Rowena stopped at a cafe on the way to the beach. Part A, I. How many minutes did Rowena take to drive to the cafe? So from here to here is that journey to the cafe, because this is the part where they've stopped. So from here to here is the time. So we've got 12 till 1 p.m. So this must be 12:30. So that tells me it took 30 minutes to drive to that cafe. Then it says, write down the distance from Rowena's home to the cafe. So this is home, this is the cafe, so we're reading along this way now. So the distance is 10 miles. Okay, part B and C then. So Rowena stayed at the beach for 1.5 hours. She then drove home without stopping and arrived home at 1600 hours. Part B, on the grid, complete the travel graph. So she stayed at the beach for 1.5 hours. So let's pop this down here. So this is where we're at the beach. And if we read all the way down here, we're at the beach at 13:30. She stayed there for 1.5 hours. So half an hour takes us to 2. And then another hour takes us to 3. So if we follow that up, we need a stationary horizontal line here for staying at the beach for 1.5 hours. Then she drove home without stopping and arrived home at 1600. So 1600 is here. We're going straight from the beach to home, not stopping anywhere. So we're going to draw the line there like that. So that's part B. Part C, work out the average speed for the journey from the beach to Rowena's home. Okay, so part C, you've got speed, distance and time. So from the beach here to home is 35 miles. So the distance is 35 miles. And the time taken, well, we've left the beach at 3 o'clock. We get home at 4, so it's only taken 1 hour. And we want it in miles per hour, so it's taken 35 miles per hour. Question 14. 120 boxes cost £6. 270 bags cost £10. A bag is cheaper than a box. How much cheaper? Give your answer in pence correct to 1 decimal place. Okay, so if we've got bags and their price, so 270 bags is worth £10. That's what it tells us here, look. And then if we've got boxes and price, 120 boxes is £6. So we're going to work out the cost of 1 bag and 1 box, and then we're going to compare them. So we're going to divide by 270. So that's in pounds, remember, 0.04 rounded to 1 decimal place to 2 decimal places because it's money. So that's, want our answers in pence. So that is actually 4 pence per bag. Let's do the same over here. So we want 1, so we're going to divide by 120. So 6 divided by 120 is 0.05 pounds, which is 5 pence. So a bag is cheaper than a box. Well, it is. A bag is 4 pence. A box is 5 pence. How much cheaper in pence correct to 1 decimal place? So it's 1 pence cheaper. There's no need for decimal places there on that one because the difference between 4 pence and 5 pence is 1 pence. Question 15. There are only red beads and green beads in a bag. The number of red beads to the number of green beads equals the ratio 1 to 4. There are 35 red beads in the bag. Work out the total number of beads in the bag. So we've got red to green is 1 to 4. Tells us that 35 are red. So to get from 1 to 35, we would have multiplied by 35. So we need to do the same on the other side. So 4 multiplied by 35 is 140. It wants the total number of beads. So we're going to do 35 red plus 140 green, which is 175 beads in total. Question 16. Describe fully the single transformation that maps shape A onto shape B. So we're starting with shape A, we're moving to shape B. So shape A has not been reflected over the x-axis. It has not changed size in any way, so I'm going to assume it's been rotated, so turned around. So I'm going to start by saying it's a rotation. And then what I'm going to do is I'm going to trace over the shape here. And I'm going to put an arrow there. And then what I'm going to try and do now is figure out what point this shape has been rotated around to get to B. So I'm going to start here at the origin first. So if I put my pencil on and I move that, oh, that was handy. Okay, so if you notice, we've gone anti-clockwise and the arrow is now turned 90 degrees. Because if you look, started here, now it's at a right angle of 90 degrees. The triangle has matched exactly, so that tells me it's also been rotated around this point here, the origin where my pencil is. So that arrow shows me how far around it's gone, so it's taken a quarter turn, 90 degrees, anti-clockwise, and around that point 0, 0. So it's a rotation, anti-clockwise, around, you can put the origin or you can put 0, 0. For 2 marks. Question 17. The diagram shows the position of Tower T. So this is Tower T and they've drawn us a north line here. That's a good indication that we're going to be working with bearings. Town R is 55 kilometres from Town T on a bearing of 065 degrees. So bearing of 065 from T. So they've drawn us the north line. And we're going to draw a 065 bearing from here, so a 65 degree angle. So I'm going to pop the centre of my protractor on T and I'm going to make sure that this 0 line lies flush with the north line, so this 0 line here. And then we want a 65 degrees, so 065 from T. So we're starting at 0, we're going round to 065 and I'm making a mark there, look. So that's our angle of 065, our bearing. Now we need to figure out how far away from T this town is. So it gives us a scale of 1 centimetre is 10 kilometres. So we've got 55 kilometres. So that's kilometres, that's centimetres. So 1 centimetre is 10 kilometres, but I've got 55 kilometres. So I need to figure out how many centimetres. So what I'm going to do is I'm going to divide by 10. And that should tell me, hopefully, how many centimetres. So 5.5 centimetres. Okay. So get your ruler. So what you want to make sure is that the end of your ruler is here and that you're matching up with that angle as well, that bearing that you've plotted. There we go. And then we're going to go to 5.5 centimetres, which is here. So you draw your line, making sure it cuts through the mark you made for the angle. And then this point here at 5.5 centimetres is position R. It says to mark it with a cross, but I'm also going to pop R there as well, just in case. Question 18. Solve 4 inside brackets 2x subtract 3 equals 20. So the first thing I'm going to do is I'm going to expand the brackets. So 4 times 2x is 8x and 4 times negative 3. Remember, if you're not sure about negatives, you can do it yourself. 4 times negative 3, negative 12 equals 20. Now I'm going to add 12 to both sides to do the inverse of subtract 12. So 8x equals, use your calculator if you need to, it's not a problem. And then I'm going to divide by 8. So x is 4, goes on my answer line. Question 19. Jenny invests £3,000 for 6 years at Y% simple interest per year. At the end of the 6 years, Jenny has received a total of £450 in interest. Work out the value of Y. So we would have worked out how much interest for 1 year, and then multiplied it by 6. So let's do the opposite of that. So 450 divided by 6 is £75. So they get £75 per year interest. So now I'm going to find out what percentage of 3,000 that £75 is. Okay, so £75 out of 3,000 and then multiply it by 100. Calculator is our friend. So £75 out of 3,000 multiplied by 100 tells me that it's 2.5%. So Y is 2.5 on the answer line. Question 20a. Simplify m to the power of 2 inside brackets all to the power of 3. So this is the power of a power rule. So what this tells us is that we multiply the powers together. So m to the power of 2 times 3, which is m to the power of 6. Part B. Simplify x to the power of 5 multiplied by x to the power of 8. The law of multiplication for indices says that if we have the same base, and we're multiplying, we then add the power. So it's going to become x to the power of 5 plus 8, which is x to the power of 13. Part C. Expand. 4p multiplied by p squared is 4p cubed. 4p multiplied by positive 3p is positive 12p squared. Really important with these powers to make sure they're smaller like that, guys, so that they're clearly read as powers. Question 21. Johnny wants to know how much coffee he will need for 800 people at a meeting. Each person who drinks coffee will drink 2 cups of coffee. 10.6 grams of coffee is needed for each cup of coffee. Johnny assumes 68% of the people will drink coffee. Part A. Using this assumption, work out the amount of coffee Johnny needs. Give your answer correct to the nearest gram. Okay, so if there are 800 people at the meeting and he assumes 68% will drink coffee, let's find 68% of 800. And find out how many people Johnny assumes are going to drink coffee. So I'm going to do 800 divided by 10, which is 80, that's 10%. And then I want 60%, so I'm going to multiply this by 6. 80 multiplied by 6 is 480. So I've got 60%, I want 68%, so I need 5%, 1%, 1% and 1%, because then these will add to give me 68%. So 5% is half of 10%, so half of 80. And then 1% we divide by 100. So 800 divided by 100 is 8, and we want 3 of those. So these digits here are what we're going to add together for our 68%. $544. You could have also used a multiplier. You could have gone 800 times 0.68. So 544 out of the 800 people, he reckons they're going to drink coffee. He reckons they will drink 2 cups of coffee each, and each is 10.6 grams. So let's do 2 times 10.6. So we need 21.2 grams of coffee per person. And there's 544 of them. So let's do 544 multiplied by 21.2. Which is 11,532.8 grams of coffee needed. We need the nearest gram, so 0.8 means we're going to round that up to 11533 grams. So 11,533 grams of coffee. It's a lot. Okay, Johnny's assumption is wrong. 72% of the people will drink coffee. How does this affect your answer to part A? Well, we were working out 68% of people. 72% is more, so our answer will be larger. So will be bigger, more coffee would be needed. She's just simply explaining what's going to happen with that change in the percentage there. Question 22. ACF and ADG are straight lines. So ACF, ADG, straight lines. BCD and EFG are parallel lines and they're marked by these arrows here. Show that the triangle ACD is isosceles. So triangle ACD is this one here. And it wants us to give a reason for each stage of our working out. So what do we know about isosceles triangles? They have two sides the same, and then their base angles are the same. So we've not been given any information about the sides apart from their straight lines, or that we've got some parallel lines in there as well. So we can't actually use this fact, but we can use the fact that the base angles in an isosceles triangle are the same. So we would expect two angles within this triangle ACD to be exactly the same if it's isosceles. So let's work out what we can until we get to figuring out the angles inside this triangle. So the first thing I'm going to do is I'm going to do this angle here, FCD. So FCD equals, let's put angle FCD, so that's a symbol for angle. Angle FCD, so this is, you've got two parallel lines and we've got this Z shape here. So this angle and this angle are equal. So FCD is 125, and I'm putting it here and on my diagram because alternate angles are equal. Okay, because of that Z shape. Now that I know this angle, I can find this angle. So angle ACD, because angles on a straight line add to 180. So 180 subtract 125 is 55. So this is 55. So angles on a straight line sum to 180 degrees. Okay. Now you can do this angle here for exactly the same reason. So angle ADC is 180 subtract 110, which is 70. So this is 70. So we're going to find out this missing angle. So the angle here, CAD, is 180 subtract 55 and 70 because it's a triangle, which is 55. So it's 55 there. We have to say angles in a triangle sum to 180 degrees because we've got to give these reasons. And now we've shown, so we can say here, two angles are equal, so triangle ACD is isosceles. We needed to find that third angle, didn't we, to figure that out. Question 23. It takes 14 hours for 5 identical pumps to fill a water tank. How many hours would it take 4 of these pumps to fill another water tank of the same size? Okay, so time and then pumps. So 14 hours for 5 pumps. We're aiming for 4 pumps, so let's figure out how long it would take 1 pump. So we're going to divide by 5. 14 divided by 5. So it would take 2 hours for 1 pump. We want to figure out how long it would take 4 of them then. So we're going to multiply by 4. So it would take 11.2 hours for 4 pumps. Question 24. A and B are numbers such that A equals 2 squared multiplied by 3 to the power of 4 multiplied by 7. B equals 3 squared multiplied by 7 squared. So these are in product of prime factor form, okay, in index form. Part A, find the highest common factor of A and B. So to find the highest common factor, we're going to multiply all the common prime factors. So I'm just going to extend this out a little bit. So A is 2 times 2 for 2 squared, times 3 times 3 times 3 times 3, 4 of them for that power of 4, times 7. I'm going to expand B as well. So it's 3 times 3 times 7 times 7. And now what I'm going to do is I'm going to pull out what they have in common. So I can take a 3. I can take another 3. Can't take any more 3s from B, so they have to stay where they are. I can take a 7 from each. So the highest common factor is 3 times 3 times 7, which is 63. So I'm going to put 63 here. Find the lowest common multiple of A and B. So the lowest common multiple is everything multiplied together, but these things here that we've taken out as the highest common factor, we only use them once. We don't use them twice as they appear in those lists. So we're going to do the highest common factor multiplied by what's left up here. So 63 times 2 times 2 times 3 times 3 times 7. $15,876. Question 25. Lava flows from a volcano at a constant rate of 11.9 meters cubed per second. So that's in seconds. How many days does it take for 67,205,600 meters cubed of lava to flow from the volcano? Give your answer correct to the nearest day. Okay, so first things first, we're going to divide this amount of lava by the rate at which it's flowing out. So 67,205,600 divided by 11.9. So 5647529.412. So that's how many seconds it's going to take for this lava to flow. So this is seconds. We want it in terms of days. So we need to go from seconds to minutes. So we would times by 60. Then we need to go from minutes to hours. We would times by 60 again. 60 seconds in a minute, 60 minutes in an hour. Then we need to go from hours to days. So we would times by 24 because there are 24 hours in a day. So we're going to do this sum in one big lump. We're going to do this that's still in our calculator, multiplied by 60, multiplied by 60, and multiplied by 24. So multiply by 60, multiply by 60. No, we're not. We're going to divide. Silly me. Way too big a number. So 5647529.412 divided. Silly me. Divide by 60. Divide by 60. And then divide by 24. So that is 65.36492,375 days. Okay. To the nearest day. So it's 65.3. That's 3 is less than 5, so it's not going to change it. So it's 65 days to the nearest day. Question 26. Here's a graph of y equals x squared, subtract 2x, subtract 2. So this is a quadratic graph. It's a positive x squared, so we've got this U shape here. Part A, write down the coordinates of the turning point of the graph y equals x squared, subtract 2x, subtract 2. So it's the same equation. The turning point is this point on the graph here where it starts to become symmetrical and reflects on itself. So we're going to read the coordinate of this turning point. So x first is 1 and then the y is -3. Write down an estimate for one of the roots of this quadratic, x squared, subtract 2x, subtract 2. So the turning point is the line of symmetry. The roots are on the x-axis, so where it crosses the x-axis. So here and here. So estimate for one of the roots. So we're just going to read off where we think it roughly is. So this one is 2.2468. So I'm going to go with roughly 2.8 there as an estimate. And it's an estimate because we haven't got an exact scale in there. Question 27. A solid cuboid is made of metal. The metal has a density of 9 grams per centimetre cubed and the volume of the cuboid is 72 centimetres cubed. Work out the mass. So density is the mass divided by the volume, but we want the mass, so we do density multiplied by the volume. So we're doing 9 multiplied by 72. So it's 648 grams because the density was in grams. Question 28. Part A, write 9 times 10 to the power of 4 to 4.5 times 10 to the power of 6 in the form 1 to n, where n is an integer. So we want it in the form 1 to n. So on this side of the ratio is the standard form 9 times 10 to the power of 4. On this side of the ratio is 4.5 times 10 to the power of 6. So this is the side of the ratio we want to be 1. So if we're going to make this 1, we're going to have to divide by 9 times 10 to the power of 4. So we're going to have to do the same on the other side. So it's division in standard form, it's just wrapped up in a slightly different package. So this is your standard form button here. Okay, so we're going to use that now. So we're going to write 4.5 times 10 to the power of 6, an arrow off, divided by 9 times 10 to the power of 4, which gives us a big number. Will it let us change it? No. So we can actually write that on our answer line. We don't need to, it doesn't say to convert it back to standard form. Just be careful with those number of zeros. Yeah? So let's write it 1 to 5, 1, 2, 3, 1, 2, 3, 1, 2, 3. Part B, write the following numbers in order of size. Start with the smallest number. So we want to figure out what these numbers are. So 5.625 times 10 to the power of 4 is 56,250. We already know what that is. Now this one, 56250 times 10 to the power of minus 3. Put 2 multiplication signs in there, that's not useful, which is 56.25. And then let's do this one. So it's 0.005625 times 10 to the power of 5. Remember, I was using my standard form button here, guys. 562.5. So now that they're all ordinary numbers, I'm going to write them in order of size. So smallest number first. This is my smallest number. 56 is smaller than 56,562 and 5625. So this is the number I'm going to write first, but I'm going to put it in standard form in its original form. So that's the smallest, done that one. The next one is this one. And then it's this one. And then last but not least.